The lesson today is on chemical reactions and how to balance them. Let's first take a look. We have reactants on the left and products on the right. So that means these things are going to come together, react somehow, and produce these things here. What is a balanced chemical reaction? It's one in which the number of atoms on the left side is equal to the number of atoms on the right side. And also obeys the law of conservation of mass. The total mass on the left side of the reaction should equal the total mass on the right side of the reaction. We have a reactant methane, CH4, and here's a picture of it. There's one carbon, that's the black or darkened gray, and 4 hydrogens, those are the white ones. With 2 oxygens, there are 2 atoms of oxygen here, 2 atoms of oxygen here. So this coefficient in front means there's 2 times the number of oxygens. On the right side, our products are carbon dioxide. That's 1 carbon and 2 oxygens there, plus 2 water molecules. That 2 in front means there's twice the number of water molecules. There's 1 and 2. So coefficients in front, multiply the thing behind it. So since there's a 2 there, there's 2 waters. If there was a 3 there, there'd be 3 waters there. So why do we do that? Again, to obey the law of conservation of mass. Let's count our atoms. There's 1 carbon here, right there. Over here, there's 1 carbon. Here, there's 4 hydrogens, 1, 2, 3, 4, and that subscript there means 4. Over here, 2 times 2, we distribute that 2 across to get 4. Let's count them. 1, 2, 3, 4. See how there's 4 hydrogens on each side too? What about the oxygens? This says 2 times 2, which is 4. So 1, 2, 3, 4. There's 4 oxygens on this side. Here there's 2 oxygens, 1, 2. But here there's 2 times the 1 oxygen. And count them there. There's 1, 2. So you see that there's the same number of atoms on both sides of the balanced equation. And this is hopefully a nice picture for you to understand what's really going on. So a balanced chemical reaction has properly written chemical formulas with proper subscripts. It also has what are called coefficients that are multipliers that allow the both sides of the equations to balance. Let's just try a really simple one with water, or even something as simple as hydrogen peroxide. So hydrogen peroxide, H2O2, breaks down to make water and oxygen. And that's the chemical equation there. Let's take a look and count the atoms on both sides to see if they're equal. There's a little 2 here, so that means that hydrogen there is 2 hydrogens. Let me write that down there. Here there's a subscript 2, which means there's 2 oxygens. On this side here, I see there are 2 hydrogens because that little 2 there means 2 hydrogens. But I see I've got 1 oxygen here plus 2 oxygens, and that makes 3 oxygens total. And of course the 2 and the 3 don't balance out, so we need to fix that. Well, a little trick is if I've got 3 oxygens here, that's odd. That'll never balance an even number. So I got to think, how could I make this side even? Well, if I place a 2 here, that means I'm going to double my waters. So I'm going to go down here and I go, well, I've got 2 times a little 2 here. So now I've got 4 of those. But then I've got 2 oxygens here plus the 2 here. I've got a total of 4 now. So you're looking and go, well, that doesn't balance at all. Well, I think to myself, if I try to get them both to balance, now I see I've got 2 and 2, but I have 4 and 4. So if I think, let's put a big 2 in front of this, I will double this right here. So 2 times 2, that makes 4. And 2 times the 2 there makes 4. And now both sides of my equation is balanced. And that's how you go about balancing equations. Let's try another example. We have iron oxide here, Fe2O3, plus a carbon makes an iron and a carbon dioxide. I've got written down here all of the atoms on both sides. So I got a subscript 2 here. Therefore, I know I've got 2 irons. A little subscript 3, therefore I've got 3 oxygens, and just 1 carbon. On this side, I've got 1 iron, I've got 1 carbon, and 2 oxygens. And we'll need to get that balance. I'm going to apply a different technique this time. I see 2 and 3 for my oxygens. So I can go like a least common denominator. I know that that would be 6 between those two, right? Okay, so I'm thinking to myself, if I put 2 in front of this, I can go 2 times 3, and that makes 6 oxygens. But in doing so, that's 2 times 2 there. That makes 4 irons. Okay, so again, this big 2 means the whole thing gets multiplied by 2. Over here, if I put a 3, I know I can get 3 times 2, and that would give me 6. So I'm getting my oxygens to balance that way. But in doing so, I then multiply my carbons by 3. So there you go. Now it's just a matter of finishing up on both sides. See, I've got 4 irons here. Well, I can make this 4 by placing a 4 in front of this one. And I can make this one 3 by placing a 3 in front of that one there. So it makes it easy to do. But notice what I did is I saw a common denominator first, and I got my oxygens to balance. And then it's just a matter of going back and fixing the other elements. And typically that's what happens when you're balancing chemical equations. Let's just do one more example. Sodium phosphate, magnesium chloride are my reactants. Let's go through each one. I've got Na3. Sodium is 3 here. There's a little 3 there. Ooh, I see I've got a polyatomic PO4 here. So I'm going to call that 1PO4 because that's a polyatomic. I've got 1 magnesium, and I've got 2 chlorines. So that's my technique. So I'm going to call this a polyatomic ion technique because there's a polyatomic ion in my reaction. Over here I've got NaCl, so I've got 1 sodium and then 1 chlorine. The little 3 here means I've got 3 magnesiums. And over here I see, oh, I've got 2 PO4s. See, again, that's a polyatomic ion. Okay, so what I'm going to do in this technique is I'm going to get my polyatomic ions to balance first, and then I'll just tweak everything else to get it to work right. So I've got 2 on this side, but only 1 here. So let's put a big 2 in front of this. That'll now get my polyatomic ion, PO4, to balance. But 2 times 3 is going to give me 6 sodiums. Okay, that puts this one out of balance then. But that's okay, I can quickly get that to balance. If I put a 6 in front of here, that'll change this to 6. Oh, but wait, that makes this one out of balance. That's 6 here. All right, well, we just keep going until we get done. All right, I see over here, oh, I've got 2 chlorines, but I've got 6 over here. Well, I think if I put a big 3 in front of this one, that now makes 3 times the 2 there, becomes 6. Oh, but what did I do to my magnesiums? Well, remember I got to triple the whole thing, so that now makes 3 for my magnesium. I look over here. Oh, I've got 3 there. This one's balanced. So the nature of balancing chemical reactions is, finding a nice place to get started and get those things to balance first, and then tweak everything else to get it to balance. It's a little trial and error, but it works out okay.